So yeah, again, thank you, Xander, for the invitation. I'm happy to be here sharing, and thanks everyone for joining. I know there's a lot going on in the world, so I appreciate you taking the time to come talk about forests with us. So this is a study looking at the effects of wildfire on large trees, and had a really great group of co-authors. Especially want to acknowledge Caden Chamberlain, who at the time was a graduate student at University of Washington. He's now at Colorado State University, and just helped a lot with some of the analysis for this paper, and also led a companion paper looking at fuel treatment effectiveness, which is kind of a related theme to this. So yeah, again, I'm with Washington State Department of Natural Resources. It's an exciting agency to work at, and if any members have questions about what it's like working at a state agency or in this region, feel free to reach out and follow up. So we'll jump in here. And I always like to begin with kind of this landscape view, landscape perspective. And so here we have central Washington. This is the Schneider Springs Fire that burned in 2021. And this is the landscape and the fire event we'll be talking about today. And this is really interesting, what I would call a landscape mosaic across a dry forest. So this whole area burned the year before this photo was taken, and you can see a variety of fire effects, including some high severity patches, some interesting terrain, and this sloping terrain going from kind of the Washington Cascade crest down to lower elevations, and this large area of relatively low severity fire in a place where there had been a lot of prescribed fire and other forest health treatments over the recent years. So this fire became a really interesting place to study some of these questions about effects on large trees, treatment effectiveness, and this broader theme we call the work of wildfire. But just to kind of cut to the chase here, some of the key takeaways from this work is that first, landscape fires have mixed effects. So in this event, burn severity was consistent with fire regimes in different forest types, but nevertheless, extensive areas with large trees burned severely. Mature forests are not necessarily fire refugia. So in dry and moist forests, the closed canopy sites with medium and large trees tended to burn more severely than other forest structure classes. And so our management plan should have realistic expectations that these contemporary fires, they do pose a threat to late successional forests. At the same time, fire and treatments can help to restore more open and resilient conditions. Okay. So setting the stage here, I think most people are probably familiar with this fundamental fire problem in Western North America. Historically, there used to be a lot more fire on the landscape in dry forests that tended to be more low severity. And so fire exclusion has really altered these landscapes. Coupled with climate change, we have increasing fire activity, and we know that can be beneficial for many reasons, but it also threatens highly valued habitats and resources, including some of our older forests. And so land managers are very interested in identifying the most sustainable locations to keep old forests on the landscape, perhaps in fire refugia, while also restoring forest structure and beneficial fire to the landscape. So it really comes down to this question of how do we reconcile large trees and large fires on these landscapes? The context for the work I'm presenting today falls under the umbrella of the Washington 20-year Forest Health Strategic Plan for Eastern Washington. So this is an all lands, all hands approach. And really at the core, we conduct landscape evaluations to establish treatment goals, and then we collaborate with a wide range of partners to implement projects and then do monitoring. So with increasing fire activity, I really see it as an opportunity to evaluate outcomes of wildfires and management activities. And with that, we've been doing this effort we call the work of wildfire. So beginning with the 2021 fire season, and then continuing each year, we do a rapid assessment. So we put these reports out, and we're looking at what we call the work of wildfire, which is the degree to which fire effects are consistent with science-based landscape resilience and fire risk reduction objectives. So kind of going beyond just reporting acres burned or different forest types, and really trying to understand what are the effects of these fires and where are they beneficial and where are they detrimental. So just looking back across the last 40 years or so, first cut is just to look at the area that is burned. So here's fire extent across the state of Washington. And on the left, we have areas by decade. So you see this pretty steady increase in annual area burned each decade. And then for the last 10 or 11 years, you see that fires really varies from year to year. It tends to be pretty episodic. And so 2015 was a big fire year. 2021 was the second most extensive fire season in Eastern Washington. So one takeaway is that, wildfire is actually making a bit of a comeback here compared to historical amounts of fire. Another thing you see here is that there's a lot of non-forest area that burns, right? So we're pretty focused on forested areas in mostly Eastern Washington, because so far we haven't had large fire years in Western Washington the same way Western Oregon had, for example, in 2020. And then in the last decade, so we've had about 200,000 acres of forest burn each year, which is substantial. And then in 2021, we had roughly 450,000 acres of forest burn. And this Schneider Springs Fire that I'll be talking about today was the largest fire of that year. And so that burned just over 100,000 acres. And became a really interesting place to study a wide range of effects of treatments and outcomes for large trees. Putting that same information on a map to show you the last few years of large fire activity. So in green is that 2021 fire season. The Schneider Springs Fire was located right here. So it's kind of just east of the crest of the Cascades running through the state of Washington and down to lower elevation. And so you can see also all these gray areas. A lot of this is that non-forest area burning. And then more recently, these large, more colorful fire polygons. These are the large fire events the last 4 years. Okay. So zooming into this particular paper, we addressed 3 related and I think pretty straightforward questions. So first, are burn severity distributions consistent with historical fire regimes in different forest types, specifically dry, moist, and cold? How does burn severity vary with forest structure, particularly large trees with open versus closed canopies? And finally, how do fuel reduction treatments influence forest structure and burn severity inside and outside of treated areas? I won't go deep into the methods, but just so you know, all the different pieces of the puzzle here that we're working with. So we identified forest types and fire regimes using a potential vegetation type map covering the East Cascades. We classified more fine-grained groups into dry, moist, and cold groups. And we have estimates of the historical range of variation, fire severity from the Land Fire Project. We estimated pre-fire forest structure using digital aerial photogrammetry, or DAP. And we have these bins of small, medium, and large trees and open versus closed canopy. So very broad buckets, but in general, small is areas with trees less than 10-inch diameter, medium is 10 to 20-inch, and then large trees are above 20-inch diameter. And we're calling it open if it had less than 50% canopy cover. And when I talk about forest health treatments, the database was compiled from federal and state records, and Caden Chamberlain really led the way on that effort in his 2024 paper. For the burn severity assessment, we use a satellite-based relativized difference in normalized burn ratio, which is a pretty standard metric, using a Google Earth Engine composite approach. And we classified into low, moderate, and high severity corresponding to less than a quarter, 25 to 75%, and then 75 to 100% basal area mortality. And then finally, what you'll see in terms of analysis, there's a fair bit of geospatial overlay where we're combining these different maps. And then we're quantifying effects using a generalized additive model framework. And that allows us to account for biophysical drivers across the landscape. And there's ongoing other work addressing other work of wildfire metrics that we won't get into today. So jumping into the landscape itself, I'll show a series of maps here just to illustrate the gradients that this fire covers. So on the left, we have the broad forest type groups, and then on the right, the potential vegetation types. So basically we combine ponderosa pine and dry mixed conifer into the dry forest group. Moist mixed conifer is the moist group, and then the mountain hemlock, silver fir, and subalpine parkland zones into this cold forest types. I know this is pretty specific to the Cascades, but in general, these dry, moist, and cold forest types are similar to broader gradients across the western US. Okay, and then in terms of forest structure, here are those 4 bins I talked about: the small, medium, large closed, and large open. So you can see there's sort of a wide distribution of forest structure classes across these different forest types, a fair bit of medium-sized forest, and that the large open tends to be interspersed in smaller patches or pixels across the landscape than the large closed patches. To help your eye focus on some of these spatial patterns, I just picked a couple of areas mid-slopes on this fire. And so here's an example of the forest type on the left and then burn severity gradients on the right. So you can see these pretty large patches of high severity fire in red, as well as some extensive areas of low severity fire in blue, and then a fair bit of what we call moderate severity. So this fire event, as it developed over time and as it really played out, it just gives us this really nice combination of burn severity, forest type, and forest structure to evaluate these questions. And the reason we focused on this fire, particularly in the paper, is because we also had a very well-organized and robust database of treatments. So on the left here, you see sort of land management allocations. So most of this is U.S. Forest Service ground. So we have some wilderness areas in the higher elevation western portion. We've got late successional reserves in the dark green, interspersed with matrix areas in light green. And then in the pink and purple, these are state lands. So we've got some Washington DNR lands in the lower elevation eastern part of the fire. And so these treated areas, you can see, are distributed kind of throughout that middle and eastern portion of the fire, mostly in the dry and moist forest types. Okay, so getting into some of the results here, one way to evaluate the alignment of contemporary burn severity with historical estimates is just to put it on this type of bar graph. So here we have low, moderate, and high severity bins on the x-axis and the extent of severity on the y. So in the dry forest types, we generally had more of the low severity and less of the high. And in the gray bar is our historical estimate. So in general, you can see this is corresponding to that pattern. And then in our moist and cold forest types, as it played out, this fire had what we would call sort of well-behaved in terms of overall severity patterns. It had generally lower severity in the dry forests, mixed in the moist, and then tended to be higher severity in the cold forest types. I will say that our historical estimates of severity in cold forests in particular need some refinement. And there's certainly, in contemporary times, we've had a lot more of this mixed low and moderate severity and not as much of the high severity dominated effects in that cold forest type. But, the first cut of this fire, even though it was the largest fire in the state, it followed this general pattern going from dry to moist to cold forests. So here's some photos to illustrate this gradient. So on the left here is a dry forest area that's relatively lower elevation, and you can see the large trees in this photo survived the fire, relatively low severity. And then on the right, we've got kind of a gradient between moist and cold forests at the higher elevations and more of a mixture of high, moderate, and low severity. But what about the large tree structures themselves? So another way to look at severity by forest type is with the distribution, not just the classified. So this tells us the same thing, that as you go from dry to moist to cold forests, you tend to have higher severity overall. But you can also slice and dice it by forest structure class. So across all forest types, we see relatively lower severity in small and large open structures, and a little bit higher severity in medium and large closed. And that's where we start to see this evidence of a divergent fire effect in the large closed and the large open structure classes. We took this a step further. Oh, one thing I wanted to point out, In the large forest is actually both large closed and large open. About 30% of that large tree habitat that was there before the fire experienced high severity fire. So it's not all good, it's not all bad. We have sort of potentially restorative effects with lower severity fire in large open structures, but we still have some areas in those large open forests that are experiencing high severity fire. One of the reasons we call wildfire a relatively blunt tool when it comes to restoration. So that was just telling you what was distributed on the landscape, really just observing what's out there in more of a kind of geospatial framework. Here we're now modeling the effect of burn severity, the effect of forest structure class on burn severity using the generalized additive models. And so we see that it's splitting things out a little bit more completely and looking at it by forest type. And so across all forest types combined, we see significantly lower severity in the large open and the small forest structure classes. And that was also very pronounced in the dry forest types. Similar patterns in moist and cold, but not as much separation in terms of that modeled effect. So here's an example again of that large open site on the left with relatively low severity outcomes, and on the right, a large closed area where the trees were packed together and had denser understory trees, and all the overstory trees were killed in that case. So now we're going to pivot more to the treatment effects piece, and I'm happy to go back to these structure class parts of the analysis too, if folks want. Okay, so in addition to the forest type and forest structure, we can look at what was the distribution of treatments in these areas before the fire. So this graph on the left is just showing what we're calling outside treatment, which is more of a control condition, and it's just a buffered area up to 1,000 meters from a given treatment on the left, and then different treatment types. So prescribed fire, wildfire, thinning alone, thinning plus fuel treatment, which is really a pile burning or surface fuel rearrangement, and thinning plus prescribed for fire. And we know from the literature that the combination of thinning and prescribed burning tends to be the most effective when it comes to mitigating subsequent wildfire severity. So this is just telling you what's the distribution of treatments that were out there and the different combinations, and then pointing out that really prescribed fire was pretty limited. Most areas that had prescribed burning already had some thinning beforehand, and that thinning combined with that surface fuel treatment was the most extensive treatment type. Same information, but just shown on a relative proportion. That shows us that the wildfire area actually had the highest relative abundance of large open structure, and that the control or areas outside of treatments had the least amount of that large open structure. Okay, so now we're going to take it one step further and then compare the burn severity inside and outside of treated areas. So this is combining all the treatments. Okay, so the information we saw on the previous slide, it's collapsing that into either treated or outside of treatment areas. And looking at the modeled burn severity, comparing inside and outside. So here on the y-axis is again burn severity. And we can see in the large open forest structure class, higher severity outside of treated areas. Okay, and these are even areas that were large open structure, but not treated. And then when we look across the other forest structure types, we see a pretty consistent pattern. Wasn't statistically significant in the small forest type, but in general, we have higher severity outside of treated areas than inside. This is not a huge surprise. It's pretty consistent with other studies across similar forest types. But one thing we were able to do is take it one step further and look at this distance to treatment effect. And I'll say that there's ongoing work on this theme, and various folks, including Caden, who I mentioned, are looking at this across multiple fires and broader landscapes. So really, this is just an initial teaser of this kind of landscape effect. But interestingly, in the large open forest structure class, there's really no difference with distance to treatment edge. You can see it's a very flat line, and it's all pretty low severity in those large open structure classes. However, when we look at the other structure types, one thing that really caught our eye was that in this large closed forest structure class, there was a significant effect, and there tended to be lower severity closer to treatment edge and higher severity farther away from treatment edge. So this has big implications in terms of when you're designing treatments to do restoration and you want to protect some areas as large closed canopy forests, you may have a strategic option for locating treatments adjacent to the really high value areas, and that provides a shadow effect next door. And so here's just another example, the same large open site with relatively low severity. And then here's an example of a large closed site with low severity that was relatively close to a treated area. Okay, so trying to put all the pieces together here, and some of the implications for adaptive management. One is that these large fires are here to stay. Schneider Springs was the largest fire of 2021, and it had 107,000 acres burned, really substantial impacts on the ecosystems as well as communities in terms of smoke, especially in the Yakima Valley. And then the last couple of years have had relatively lower fire extent than 2021, but it's only a matter of time till these areas burn. And we need to figure out how we're going to adapt and live with fire on the landscape. In terms of late successional forests, these areas with large trees are vulnerable to fire, but they're also highly variable. And we know that many of these areas historically had much more open structure with large trees, and that was due to fire. So by monitoring the work of wildfire, we can continue to support collaborative forest planning and management, community fire protection, as well as climate adaptation. And just a reminder that we have these ongoing assessments. So there's a couple links. There's the 2021 edition where we included the Schneider Springs analysis. And then our most recent one, 2024, we're gearing up for the 2025 fire season, which was a pretty interesting one in Washington where we had relatively little fire extent over the course of the summer, but the things really kind of got going in September. So we had this late season expansion of fire with some interesting effects in the Cascades, especially. And so back to my overall points, really these landscape fires have mixed effects, and we see in cases that burn severity can be consistent with fire regimes, but you're still going to have trade-offs in terms of large trees and tree mortality, that mature forests are not necessarily fire refugia, and that closed canopy sites with medium and large trees tended to burn more severely than other forest structure classes, especially the large open, and that management plans really need to be adaptive and realistic, recognizing that contemporary fires are threatening these forests, but we also need fire and treatments to help restore more open and resilient conditions. Since it's Halloween, I couldn't resist throwing this in there. I think we have plenty of time for questions and discussion. So thanks so much for your time. And yeah, happy to take any questions.
That's great. I love a little humor. And I have a ton of questions. So other folks should put questions in the chat, because otherwise I'm just going to ask Garrett all sorts of stuff. And I'm curious, first off, while we're waiting for other questions to come in, what was the motivator for the 2020 starting this series on the work of wildfire?
Yeah, that's a great question. It was mostly just the confluence of a large fire season happening and having sort of our team in place where we'd been working on this 20-year plan. And so I think the 2014 and 2015 fire seasons really got people's attention in Washington. It set up the agency to establish this, what we now call our Forest Resilience Division in the 20-year plan. And then our team was kind of built up and ready to do this kind of analysis beginning in 2020, 2021. And so it was just sort of that the time was right. And we've been continuing it every year since.
And I ask because we've tried to do something maybe not quite as analytical, but similar in the Southwest, just documenting the year's fire season and trying to help folks understand, partly because the information disappears from INCIWeb and other sources, and it can be 5 years later, you can't remember what happened in that year. So I'm really pleased. I hadn't known about the Washington series, and so I think that's a great addition. And I put the link to the 24 work of wildfire assessment in the chat, and you can grab that. And I can't believe other folks don't have questions, but I still have lots. So I'm gonna die. Oh, here we go. So Mike asks, how much of the large open forest area was large closed prior to the treatments? So you map out treatments. Did you differentiate like recent change versus um, sort of I don't know, just structure that might have been more naturally driven?
Yeah, that's a really good question, Mike. I think part of what you're getting at, even in this photo, you can see there's like an edaphic effect, and there's some terrain where some of these open areas, maybe with some large trees, would be open anyway without previous disturbance or treatment. Actually, now that I'm looking at it closely, I think this photo might include portions of what was called the Meeks Table Fire 2015, which was our previous wildfire treatment in the study. I don't have the exact numbers. I would, it's certainly a mix out there, and there's definitely been an extensive footprint of treatments in this area, concerted effort in the last 20 years. So a lot of the treated areas retain large trees and tended to more be a large open structure. And I can't tell you the exact number. I think that's a really, really good question. So I can go back to the data and follow up with you. Um, yeah.
Good. It's always a good question when you send the scientist back to the data.
Yeah.
um, Aja asked if you have any thoughts on delayed conifer mortality in the Schneider fire footprint and if that might affect the study at all.
Yeah, that's a really good question, Asia. This area certainly had some delayed mortality, especially in some of the higher elevation cold forest types like the silver fir zone, but also in some of those dry ponderosa pine sites where these old trees. Um, and I encourage folks to check out James Johnston's talk, the recording of it, if you hadn't seen it yet, because he gets into some of these topics of how large trees, especially in this mixed conifer kind of forest, are stressed and are vulnerable to mortality even without fire. So when there's a large fire, a certain number of trees will survive the initial effect, but they're not going to make it through the next couple of years, especially if it tends to be hot and drought. Um, so, if anything, that would make our results a little less optimistic, perhaps. It would show probably in the dry forests a little bit less low severity, maybe a similar amount of moderate and a little bit more high severity. I think that's kind of a key implication as we move forward. And actually, for this year's 2025 report, we are planning to include more of a retrospective look at 2021 because it still is the biggest fire season we've had while we're doing these work of wildfire reports. And we'll probably put out an updated graph that shows kind of how that severity distribution changed over the first 3 years following fire. I think overall, some of the takeaways would still remain the same. The areas with open structure will still have fared better than the areas with closed structures. And the differences by forest type, I think, will still be pretty evident. And perhaps the cold forest types will have that uptick in high severity, but that will be more in alignment with what we have for historical estimates.
Mm. Yeah, thanks. That's great. So there are two questions on sort of the treatment shadow effect. Annalise asks about thoughts on the distance to neighboring treatments for large adjacent trees to benefit.
Yeah. Well, we can go back to that this
Yeah.
slide here. I mean, the first thing I'd point out again is like this is really more of a teaser effect or a teaser result. If you look at these scatter plots, right, and focusing specifically on the large closed, it's pretty widely distributed, and so this fit line is a significant slope. But there's still a lot of variation, and the whole fit, this is our kind of 95% confidence interval and fitted line. It's all in this moderate severity zone. So the difference between being really close to a treatment and being a kilometer away it's important, but it's not a huge difference. And so I don't know, to put a number on it, I think the closer you are, the better you are, and it's probably not linear. And it gets into also some of the related questions we've been working on in terms of fire operations and how do these treatment areas allow firefighters to engage in terms of putting in fire line or back burning, and sort of deciding which areas are appropriate for resource management objectives, letting fire burn into those areas. And so, yeah, I think there's another way to look at this is to look at the direction of the fire spread using wind, because right now this analysis is looking at all directions around a given area to treatments in any direction, but we know that fires move in specific directions. So I guess I don't want to overinterpret or speculate too much, because this really was just an exciting little teaser that we found, and there's more in-depth study going on to quantify sort of how much of a treated landscape or how much of a landscape treatment area in terms of percentage really kind of flips the script in terms of fire outcomes in untreated areas.
Yeah, that makes sense, and we'll all look forward to that forthcoming research, because it does get very complicated. I think the active fire management or suppression is a huge issue that's hard to trace. And then obviously wind direction too changes all the time. So yeah, that'll be good to follow up on. Um, Nick asks a question about mature forests burning at high severity, particularly for the moist, large closed forests. And he's curious if there's been an effect of being relatively even-aged homogeneous. So we've seen some studies. There's a new paper out on burning in plantation, that kind of issue where does well, I'll just continue with next question. Perhaps burning at high severity is due to the homogeneity, and so would a more heterogeneous forest, like an older growth forest in moist conditions, have burned at that severity as well? Can you
Yeah,
comment on that?
it's a really interesting question, because we have these relatively coarse bins of forest structure we're talking about here in terms of small, medium, large closed, large open. And so if it's large closed, like I think, Nick, part of what you're getting at is that it could be a relatively even aged large closed, or it could be more uneven age with large trees,
Yeah.
but a closed canopy because there's understory trees. So we're not, in this analysis, we're not splitting things out in a specific way to address that. I think in general, just based on my experience in the field, in this fire and other areas, when you do have a large tree component in a closed canopy, it tends to be more multi-storied, because the closed canopy part, when there are large trees, is really coming from shade tolerant trees like grand fir, Douglas fir. Not always, but that's kind of the typical, I'd call, late successional forest condition on the east side. And a lot of these areas we know are relatively new on the landscape in terms of emerging from fire suppression and exclusion over time. These areas used to burn more frequently from lightning and from indigenous stewardship. And so with the exclusion of fire, we've had this densification and more contemporary removal of the large tree component. I think, to your point, though, the large trees, when present, the really large old trees, tend to be more fire resistant if they have thicker bark, higher canopy heights. And especially those are the elements that in the large open condition are being protected and sort of reinforced through treatments. And like Mike pointed out, not all the large open areas are treated areas, but the places that are, that's really, I think, the goal of a lot of this restoration work is to make the structures more resistant to fire, but also more resistant to drought, and try to sustain those large trees as long as possible. But the trade-off is then you're really a different habitat type. It's not a multi-layered forest that might be considered adequate, nesting habitat for something like a spotted owl, but it might be very good for something like a white-headed woodpecker. And I'm sure we could have a whole series about habitat sustainability and the spotted owl topic in terms of which areas in the landscape are really the most suitable. And I'll share a paper that Josh Holofsky at our agency led that came out last year as well, that really grapples with this question of how do you reconcile the dilemma of restoration of landscapes while also sustaining some dense forest habitats in the most sustainable locations.
Yeah, definitely a challenge. Yeah, across the West. Okay, let's see. Let's see. So let's see. There was yeah, maybe you've already touched on this, but just to call out the question more specifically, Lanthropus, if you have any thoughts on the appropriate size of large closed forest areas that can be maintained for heterogeneity habitat that are small enough to be protected from high severity wildfire. So I think it's right along the lines of the Josh Holofsky's paper.
Yeah, appropriate size. Yeah, I that's a really good question. And I think this is probably where I put my scientist hat on and say, well, we share this information with our manager partners and our collaborative groups, and then we talk about it. But I think one of the key things is to not have large uniform patches of any one condition on the landscape. And so that's one of the things that fires tend to do. They tend to create heterogeneity and kind of blend across the landscape. So even as we talk about like treatment edge and distance to treatment, that's one difference between a silvicultural prescription typically is that it's got boundaries, it's a stand, whereas historical fires, especially fires layered over time, create much more diffuse edges. All of which is to say, I think I would go back to the historical records and interpret, where on the landscape we had patches of large, dense forest and more large open forest, and use that as a template, both in terms of like the amount of, the appropriate amount of large closed canopy forest, and also kind of the spatial patterning. And we do some of that kind of work in what we call landscape evaluations for a given area. Asia Woodrow, who's on the call here, he's a wildlife biologist with many years of experience and a really good grasp of the literature. So I'd be curious to hear what he has to say in terms of the appropriate amount and location or spatial pattern of dense forests on the landscape. And I also see Nick's comment you're right. The 20-inch threshold, it's not just differentiating the old or very large trees from sort of mature and large. And so that is more that we could dig into to really to tease out, which locations had really more old growth conditions. But yeah, these are really, really good questions. And I see that Xander also posted the Holofsky paper I mentioned, which again, it kind of looks at historical amounts of suitable habitat for spotted owl in this case, and then also looks at where in the landscape we might have kind of the most, based on drought and fire risk, basically kind of the most sustainable locations. Asia, do you have any thoughts for the group?
No thoughts. The topographic template of the landscape might be your best shot at success.
Sorry to put you on the spot. Can you build out the topographic sort of assessment of the landscape just a little bit? You're looking at sort of wetter spots, drier spots, ridges, valleys, that sort of thing.
Affirmative, maybe. Yeah. Let the landscape let you know what is practical and possible, instead of maybe one studying one thing from a different place and applying it in a different place.
Yeah, some of the tools that we use along those lines, and we do in the Eastern Cascades especially, use photo interpretation from historical imagery going back to the 1930s, which of course is not the longest history, but it certainly is a different landscape than what we have today. And that informs what we call restoration goals or landscape evaluations and historical amount of habitats. And the fire history studies that have been done kind of throughout the region also tell us a lot about the amount and types of fire and the forests that were in place in these landscapes.
Yeah. Mike added another question about the fire itself. Do you know how long it took, how many days it took for the majority, say 90% of the area to burn?
Yeah, that's a good question. Like many fires, this one, especially many large fires, there are these initial kind of blow up phases where they exceed initial attack, right? So I was going to mention 2021. I don't know if you all remember, it feels like a long time ago, but I had the heat dome event in the Pacific Northwest, and it was a pretty extraordinary feature, like really high temperature, early summer, and a lot of places were dry and hot early on. And we wound up with the bootleg fire in Oregon, quite a lot of fire extend across Eastern Washington and Oregon. So the Schneider Springs Fire didn't get going until August, but the landscape was primed. The exact percentages, I'd have to go back to the progression map, but it really blew up in that the first few days, covered a lot of ground, and then had 2 or 3 other phases where the fire weather switched kind of from low and moderate conditions to more extreme. So I think the majority of the area burned in just a matter of days, probably in 2 different phases. And then a lot of the rest of the fire, it kind of filled in right around those bigger blowups. So yeah, it's a really, really interesting question. And I think it's a pattern that holds, for most large fires, that there's sort of an initial blow-up phase, which is why it became a large fire, and then it kind of takes on a life of its own. And then there's the whole question of how do fire management decisions influence the overall shape and spread of this fire. So in this case, on the southern boundary, it was really defined by a large ridge, topographic feature that's a sort of a very conducive landscape fuel break, essentially, along a high ridge. I think firefighters realized that sort of an approach that incorporated that feature and then connected fire through backburning to meet the oncoming spread of the wildfire on that side played a big role. Same thing for the eastern front. So these areas with kind of lower severity oftentimes are associated with fire management decisions to put a boundary in place. And we're working pretty closely with folks in our agency who do fire suppression as well as Forest Service to think through kind of the whole pre-planning, strategic fire management. This whole work of wildfire theme connects to the PODS framework, which is potential operational delineations, and thinking about what are the areas in the landscape where full suppression response is always going to be warranted because of communities or other values at risk. What are portions of the landscape that might be more appropriate for wildfire to burn on its own? So the wilderness portions of this fire, for example. So yeah, that's sort of something we tend to call like the hidden hand of wildfire management. But when we're talking about the work of wildfire, we're also talking about the work of those firefighters and how they're helping shape the fire and the outcomes.
So just to follow up on that, were pods delineated for this area before the Schneider fire?
Yes. This area on the Okanagan-Wenatchee National Forest had pods delineated, and I don't have a map ready to go that overlays the pod boundaries with the fire, ultimate fire shape or progression, but that would be a pretty interesting exercise. Interestingly, we have in the 20-year strategic plan, we have what we call high priority planning areas throughout Eastern Washington. And this fire almost perfectly occurred between two of them. So we have less data and landscape evaluation information for this particular landscape than we do for areas just south and just north of it. But because of the analysis we've done for this fire, we also have better information about things like treatment outcomes and effectiveness. So I just, the main thing is these types of large events and the work that goes into studying them, it's really a collaborative effort. And so the folks at the Forest Service based out of the Natchez Ranger District and in the region in the ecology program have been instrumental in helping us design studies and also have these conversations about forest management before, during, and after the fire. So it's a good collaborative effort. And there's a colleague in our group, Anna Barros. She's really the lead fire scientist on the pods and what we call our dual benefit analysis. So that might be an interesting theme to bring up in another time as well.
Sorry about that. I lost my internet there for a second.
No worries.
And I've lost a little bit of the flow here. Are there more questions that we want to try to squeeze in, or should we give people 5 minutes before their next event here?
Well, Asia posted the restoration strategy for the Okanagan-Wenatchee. That's an interesting document for sure. And Mike added some interesting context that, the 2020 Labor Day fires in Oregon, about 1.3 million acres burned in the first 3 days. So, that was especially extreme east wind driven event, illustrating that kind of blow up potential.
And I think both those efforts, sort of thinking broadly with the restoration strategy and the speed of the Labor Day fires, for me, emphasize the need for pre-planning, right? Things like pods, things like where do we want to have thinning in advance or other treatments in advance, because the Labor Day fires, right? Like that's not a situation where even the best firefighting apparatus in the world is going to make a whole lot of difference. So we need to think about these things before those conditions are at that extreme level. So
yeah, and I'll just add, the nice thing, or one of the good outcomes of doing this annual report, the work of wildfire, is that now as the fire seasons unfold, people are really reaching out from different parts of the state and saying, hey, there's an interesting example of the work of wildfire on this fire and that fire. So the central Washington landscape continues to burn. And there's close to the city of Wenatchee, there were two pretty large fires that really took off in September, which was interesting. And some, I think, really interesting examples of pods and strategic fire response. And according to one of the ecologists I spoke with, some pretty extensive areas of one of the fires that had low and relatively low and moderate severity outcomes in places that maybe would not have burned or eventually would have burned from the lightning-based ignition and spread. But because of the fire management decisions to go indirect and kind of use the landscape features and pods, they got a lot more beneficial fire outcomes on that landscape. So that's certainly one of the themes that is exciting. But we're also not being naive and realizing like these large high severity patches, they're changing the landscape in a very blunt way. And so it's certainly, there's beneficial fire and there's detrimental fire, and it's all work. Some of it's good work, some of it's bad work. And that's what we're trying to figure out as these fires accumulate.
And that's a great note to end on, because I certainly appreciate your detailed analysis of this fire and acknowledging that every location is different and we have to think about our own topographic conditions. It is wonderful to have these examples and sort of understand the details of how these things are burning. So thank you so much for all the work you put into the paper itself, the research, but then also to share it with us all and being willing to entertain our questions. So thank you so much.
Yeah, my pleasure. And thank you. And thanks everyone for tuning in.
Great. Thanks all. Bye.